For our warm-up, we are looking at causation, so that means cause and effect. For number 2, it's looking at a graph that models the data. So the best thing to do on this one is put it into Desmos. And this is how it'll look. But there's this button that says Zoom Fit. I want you to click that. And it makes it where you can actually see all the points on the graph. Then you can do your matchy-matchy. So answer choice A. I didn't put in d of x equals and I didn't put y equals. You don't have to, but you can and it won't change anything. So A is not it. B is not it. C is perfectly it. And then I think D was like a -1, which changed it. So it is answer choice C. So let's go to our notes for today. So this is about all the equations that we've done so far, linear, exponential, and quadratic. So you may be given a table and asked for the function that goes with it. So step 1, know the type of equation. It will give that information within the problem. So you definitely want to read each problem carefully and underline either exponential, quadratic, or linear. Or it could just be given within your multiple choice answers. This is linear. Everybody look at linear. Y equals mx plus b. Quadratic. Y equals ax squared plus bx plus c. And exponential. Y equals a times b to the x. I want y'all to open up your journal to y'all's formula chart, which this is what you'll be given during the test. I want you to find slope-intercept form. On slope-intercept form, it's already given to you, but the only difference for the regression equation is we have a squiggly for the equal, and we have ones on the x and y. So go ahead and write this. Put that on your formula chart. So you don't have to memorize the regression equation. All you have to memorize is that you change your x and y to have ones. You change your equal sign to have squiggly.
Are we going to have a formula chart?
You will have a formula chart on your test.
But like, it won't have that on the test?
It will only have this. So you'll just have to remember if you do Desmos that you put the ones on there and you change the equal to a squiggly. I'm not exactly sure why it has a squiggly for Desmos. Okay, and then the other thing is standard form of a quadratic. It's the same equation, but we're going to do y1 squiggly ax1 squared plus bx1 plus c. And the reason we use x1 and y1 is because it's coming from a table that is named with x1 and y1. And exponential is not on here, but the exponential one is on our notes, so I'll show you that in a second. Okay, so here's the exponential one. Remember, exponential has x in the exponent. So for exponential, you do have to check this button that says log mode. That's the only way to get it to actually work and give you the right equation. So if you're wanting to write one of these equations, linear, exponential, or quadratic, you want to open Desmos, add a table, then enter the table from the data. It's important that you double check all your numbers that are in the table because it's easy to make a mistake on that. I've done it several times. Step 3, type in the equation type. So this is your linear. This is your quadratic. This is your exponential. So you'll be asked for either linear, quadratic, or exponential, and that's what you'll type in the next line. Once you type that in the next line, it'll give you your A, your B, your M, your C, whatever values are in here, you plug it back into the equation to write your equation. So step 4 says read the question, either identify the function that models the data, which means you're going to write the equation, or enter a value to make a prediction, or describe the correlation. So whenever you are describing, you'll see this word correlation coefficients. That describes how strong the relationship is between two variables. The closer it is to 1, whether it's positive or negative, is strong. But 0, close to 0, is considered weak. So if you want a strong correlation, you want it close to 1 or negative 1. And then the sign also tells you if it's positive or negative. So like a 0.23 R, that would be considered a weak positive. It's weak because it's closer to 0 than it is 1. If R is negative 0.92, because it's close to negative 1, it's strong. But it has a negative sign, so it's a strong negative correlation. That means if you look at the graph, the dots, whenever you do a scatter plot, it's all going downhill. So that's kind of what the R value represents. So to find the R value using Desmos, you'll have to enter in the linear regression equation. Okay, correlation versus causation. So all correlation means is that there's a relationship between two things. Shark bites and ice cream sales. Those are related, but one doesn't cause the other. Causation means one directly causes the other. So that's like a cause and effect. You're looking for the one that kind of makes sense as far as this makes this happen. So I want you to go ahead and look at the first example. It says, which situation does not show causation? Read through those and decide which one does not show causation. Okay. A says, when the student population in school increases, number of teachers at the school increases. Does that make sense? More students, you're going to have more teachers to teach. That makes sense. B, when the amount of sugar in a quart of apple juice is reduced, there are fewer calories. So you make sugar go down, that means calories go down. That makes sense. Okay. When there are more workers on a project, the project is completed in less time. That would make sense, right? Last one, when there's more protein in an athlete's diet, the athlete scores more points in a game? No. No, they may really just stink at shooting basketball hoops, but just getting more protein is not going to help them. Okay, so let's go ahead and go to the inside of this. Okay, for this table, it gives you height and length and says, what does the correlation coefficient indicate? about the linear association. So we want to put this in the table, and then we want to do the linear regression equation. Y1 squiggly mx1 plus b. So I have that. Then I'm going to click this magnifying glass with the zoom fit. Does this, I do have a question real quick. Is this in a straight line? No. So it is going to be weak. So mark out strong. Yes, because it's not in a line or close to a line. So it's either weak positive or weak negative. You look at R. So I want you to put in Y1 squiggly mx1 plus b and look at the R value. Write down that R value. So it's close to 0, so we know it's weak. And is it positive or a negative? It's positive, so it's a weak positive correlation. Okay, now I want you to go through the rest of these problems. We'll come back together for number 6. Okay, so let's look at number 6. It says scatter plot and table show the weekly profit in dollars earned from the sale of pastries at 7 different prices. The data can be modeled by a quadratic function. Underline that. So remember what the quadratic function? It's y1 squiggly ax1 squared plus bx1 plus c. And that is from our formula chart where we just changed the x and y to x1, y1 and the equal to a squiggly. We don't have any answer choices. We're going to have to write the equation ourselves. So what we're going to have to do is enter this in on Desmos. Let me find Desmos. Okay, I'm going to show you my Desmos. Okay, once you enter the table, hit this zoom fit button. And you can see that it's going to be a quadratic. So then you are going to enter this in. Everybody look up here. Y1 squiggly ax1 squared plus bx1 plus c. When you do that, it'll also give you the equation that goes with it. Okay, so whenever we do that, it's asking us to predict. No, it's asking us to give the equation. So here is the A, B, and C values. So here is our equation that we can write. So y equals negative 60.38x squared plus 348.14x minus 334.19. That is the equation that matches this table.